we suppose that there exists another empty state, that everything that is not defined silently transitions to that state. So this will lead you to the dead state. You have discarded the A, and you need to read that B. This is a dead state, so even if you read B, you will stay there with the empty symbol, and you're done. Once you identify the empty symbol, which is the end of your whole input string, you're done. You have read the input, you have all the transitions. If you end up in an acceptance state, you accept the string. If you don't, you reject it. This was a truncated version of ABA, so you reject it. So this path rejects it. In order to show that the whole machine rejects that string, you need to run the other path that we have left here. Right? Yeah.
So we do have to show the rejection state.
Yes, because if you need to show that it rejects, both pathways need to reject. If one of them accepts, the whole machine accepts.
Q1 rejects with a B, right? And Q2 rejects with a
Sorry.
The rejection state. Q2 is the rejection state.
Yeah, these are, we don't need to define them specifically,
Oh.
not even the rejection state. We silently assume them. Okay?
And the final example, we also have to write it out, or is it okay to just draw the end?
You mean this part?
Yeah.
If you have an input that you need to run and show if it accepts or if it rejects, you need to show the transition of the states, how you truncate the input, how you throw away the first input symbol, and the final state to show if it's an acceptance or a rejection state. Okay?
What's that last symbol there, all the way at the bottom right corner?
Lambda.
It's not-
Yeah.
Do you have to do it in that way, like, or can you, if you could show like this, the transition between states of the different?
If it's a matter of presentation, you could do whatever you want. So show me that from Q0 with an input of A, you go to Q1. And from Q1 with an input of B, you go to Q2. I don't care how you will show this, but I need to see this in a clear way.
Yeah, yeah.
So all that is just simply is the pathway explanation to why this rejects it.
Yes.
And it shows you both possibilities of like it doesn't work in this case, it doesn't work in this case either.
The machine is non-deterministic, so it will create both pathways. If one of them accepts,
Then it makes sense.
that's fine. If both of them reject, then only this is the case that it will reject. Because if I run this pathway and I reject, but for some reason I don't run this pathway, and this pathway happens to accept, then the whole machine will accept. The acceptance of an NFA is a disjunction. If either of the pathways, P1 or P2, or if you have multiple epsilon transitions, if one of them accepts, the whole thing will accept. If one of them, if all of them reject, then the whole machine will reject. But you need all of them to reject.
Right. And you would never be put in that kind of case where it's everything is and only in a DFA. You need not even a DFA, right? Because in a DFA you can only have one pathway going.
In the DFA, you know deterministically that this pathway will be followed. There's no other way.
Right.
Okay?
But non-deterministic, you know, multiple pathways.
Yeah, you could have multiple.
So you wouldn't be ever put in a situation where you have multiple pathways and they all have to work.
No.
Okay.
In the DFA, there's only one path.
Okay.
Okay?
Thank you.
Can I help you guys? That's fine. So, let's run the other pathway. Q3, with that input, we said that we had the epsilon transition, so we run from this point. With an input of A, we get where? Q4 with the rest of my input. Right? With an input of B from Q4, I get to Q5. With an input of A from Q5, I get to Q3. From Q3 with an input of A, I get to Q4. And from Q4 with an input of B, I get to Q5. I have no other input. My string is empty. You could see this as a lambda, you could see this like that. It doesn't make much difference. So I've read the empty string, the empty symbol, which is the end of my input string. I am not in an acceptance state, so the machine rejects in that pathway too. It rejects in this pathway from Q1. It rejects from that pathway. Both possible pathways reject, so the whole machine rejects. Okay? If you were asked to have a string that will be accepted, like ABA, for example, and you needed to run this, and you run the first pathway, for example, and you choose randomly to run this pathway, which is the one that should accept this kind of string. So you run this pathway, and you see that this pathway accepts ABA. You don't need to run the other one. You have found a pathway that accepts, so the machine will accept. Clear? Now, I will keep this here. I will erase also this one. And I will make the transition table for this one. It's a matter of how you want to present this, but you should have either in the rows or in the columns states and inputs, or inputs and states. I prefer states as rows, so I will start with Q0. The input symbols are A and B, so this is all I will have. So, from Q0, with an input of A, where can I go? I have an input character of A. I don't go anywhere.
Either
What would you say?
Q3.
Sorry?
Either Q2 or Q3.
Either Q2 or
I mean,
Q3?
Q1, I'm sorry, Q1 or Q3.
Either Q1 or Q3 with an input of A, right? Yes? Do I need a column for epsilon?
Yeah, I thought you made epsilon its own state.
I don't need any input to have an epsilon transition. So it means that from Q0,
Oh,
I could get to Q1 and Q3 without reading my input symbol of A, right? So I can be in Q1 or Q3. And then what can I use my symbol A for? So I will be in Q2 from Q1 or Q4 from Q3. So these are different possibilities, and this is why I define a whole set of states that I can get to. I had the transition with the epsilon, no use of symbol. I have an A that I haven't used yet, and then I will use my A to get the transition to another state. Okay? How would I do with a B? I will use my B symbol. I will have the transition to Q1 without reading it. And also to Q3. And from those two, I will read my symbol to have a transition to another state. I will use my B here. Where should I go? Nowhere. Right? And from Q3 with a B? So there's no state that I can get to. And I will define the empty set as the possible set of states that I can get to. Now, this is the transition table for the NFA. So whichever state I see here, I need to have it in my column of states. So the next one will be Q1. Let's do this a little faster. From Q1 with an A, I can go to Q2. From Q1 with a B, I can't go anywhere. From Q2 with an A, I can go nowhere. From Q2 with a B, I can go back to Q1. Next state, Q3. With an A, I can go to Q4. With a B, nowhere. Q4. With an A, I can go nowhere. With a B, I can go to Q5. Q5, A, Q3, B, nowhere. And I'm done. I defined all my states. I have all the different input symbols. I have all the the possible next states, and I'm done. This is a transition table for the NFA. Okay? Now, using this one, I will construct the transition table for the DFA. The DFA will have the initial state that also the NFA had. It will start at the same point. They need to be equivalent. So this will be my column of states again. This is my starting state, Q0. And the possible next states with an input of A. Is the set of Q2 and Q4. Or with an input of B, the empty set. I don't have the DFA in my hands yet, so I don't know what state I need to define next. I will define any state that I see on the right side of my table, and it's not previously defined. Q2, Q4, I will look at this as a state now, and I will define a new state named Q2, Q4. If you don't like this way of naming, you could name this Q6. George. However, in some way that is different from the previous ones. I like Q2, Q4, and I will follow. Okay? So, Q2, Q4. With an input of A. This is what I have. Where could I go? I erase the NFA. So, from Q2, where can I go with an input of A? You could see this here. From Q2 with an input of A, empty. From Q4 with an input of A, empty. So, the whole possible state is the empty state. From Q2, Q4 with an input of B. From Q2 with an input of B, Q1. From Q4 with an input of B, Q5. Q1, Q5 is my next state. It's a set of states because I can reach both of them and they belong to my NFA. So it's a set of states on this side of the table, but on this side of the table, since it's not previously defined, I have defined Q2, Q4. Empty, empty, that's okay. I will define this later. Q1, Q5. Actually, let's do this now. I will define the empty state. Do I need to do something? What did the empty state mean in my NFA? It meant a dead state. It was a state that I had gone there and everything should be rejected after that. So with an input of A, I should go where? And with an input of B, so this is redundant. We don't actually need to define this, but just for clarity. Okay? What is not previously defined is Q1, Q5. So I will define a new state, Q1, Q5. With an input of A, Q1 with an input of A, Q2. Q5 with an input of A, Q3. Q1, Q5 with an input of B. Q1 with B dead. Q5 with B dead. Okay? We don't need to have the NFA and looking up the arrows and all that stuff. We said that defining any machine with a transition table is full, is complete. Q1, Q5, we define this. Dead, we define this. Q2, Q3, not defined previously, I will define this now. Q2, Q3. We said that this is a set, so I will follow the notation. Q2, Q3 with an input of A. Q2, dead, Q3, Q4. So that's Q4. That's one element, so I don't need to use the set notation. Q2, Q3 with an input of B. Q2, Q1, Q3, empty. Q2, Q3 is defined. Now I get to Q4.
Quick question.
Yeah.
Do you have to redefine Q4 because you already mentioned it previously in state Q2, Q4?
This is a set of two different states. This is just one state.
Okay. Even though
They are different.
Okay. So even
Because from Q2 you have a transition that you don't have in Q4. So they're not the exact same states. So even if it's mentioned here, you need to redefine this.
okay.
Q4 is fine over there.
In the NFA table.
Q1 and Q3 were defined.
They would be-
No, I mean like the original building unit. We have Q4 and Q1. So we have to repeat in the DFA system.
Yes, it's a state of the DFA now, so single Q1 was a state of the NFA.
Okay.
Whatever we define here are states of the DFA. Okay?
When we're making the NFA, is it okay if we just define the state like Q1, Q2, like individually just before we get to it?
I didn't get it.
No.
Sure.
You-
So from Q4, the same states that we have there, empty or Q5. Q1 is not defined. I will erase this so you don't get messed up. Q1 not defined previously, so with Q1, Q2 are empty. Q5 Q5, Q3 are empty. Q2 empty or Q1, and then Q5, sorry, defined, Q2, Q3. Q3, Q4, or empty. Now, Q3 is defined, Q1 is predefined here, Q4 is already defined here, so I have nothing on the right side of the table that I have not previously defined here, and I'm done. And this is my DFA. Obviously it has more states, it's more complicated than a single NFA, but it will do the same thing. So it will recognize the exact same language. And this is why they're equivalent. Okay?
Do we have to draw it and finally the DFA?
Not necessary. If you are asked to find the NFA, not the NFA, the DFA, the table is enough because it's fully defined. If you are asked to draw, then okay, you would need to draw the states and the arrows and everything. Okay? And you could also ask if you are asked to find this.
Is it viable that we do have to have DFA and convert it to an NFA, or
Why would you do that? No, you want us not to do that.
okay.
Yes.
You tell which state is the accept state, which one of the conditional state?
So what state is the accept state? Sorry? This one? Why? How would you decide what state is the acceptance state?
You look at the
Yes. Whatever acceptance state the NFA has, Q1 and Q3, wherever you see that in here, it should be an acceptance state. So I will draw circles around the states that are acceptance states. Q1 and Q3 were the acceptance states. Wherever I see Q1 or Q3, it will be an acceptance state. Q1, Q5 is an acceptance state. Q2, Q3 is an acceptance state. Q1 is an acceptance state. Q3 is an acceptance state. Everything else that doesn't have an acceptance state of the NFA will not be an acceptance state of the DFA. And of course, Q0 is the starting state.
Is Q0 an accepting state too? Because it has a star.
Q0, was it an acceptance state on the NFA?
No, but according to the language, you can have nothing.
Yes.
And so shouldn't Q not also be an accepting state? The DFA is Q not accepting state. It wouldn't be starting from initial, like you were starting from the all everything is starting from.
Yes, you need that.
Oh, it is?
Wait,
Yeah. Is it?
Because the empty string would not be accepted by this machine.
Um,
So if you start at this point, you should accept the empty string.
So hypothetically, we have nothing in the string. It would just stop and end at Q naught because it can't even go from epsilon.
Yes. There's no epsilon in the DFA.
In the DF, oh right, because it's a DF.
Yes. Because Q3 was an acceptance state in my NFA, right? Yes, but if one of them is an acceptance state, yes.
So you know you're done with the chart when you've gone through all the states?
Sorry?
You know you've converted the
Yes,
chart?
when you have defined everything from this side in the column with the states, you're done.
So with the NFA that was just drew, it's a combination of two DFAs, right?
Yes. Small DFA. Clear? So follow the procedure and you will be fine.
Order doesn't matter on the DFA table, right?
No, but it's the natural way to do this, right? I think at least. I mean, you see a state, you get this in order. So row-wise and then column-wise. I see this, I've not defined it, I define it. I've seen this, I define it. I've seen this, I define it, and so on. And it's easier for you to write them, for us to grade, for everyone. You can write this in any way if it's correct, we will find a way. Any questions? Yeah.
So the DFA would accept Q now.
It would not accept Q naught. It would accept an empty string. The machine does not accept a state. It accepts an int.
So it would accept the empty string, which
It
would
should
be
accept the empty string because
Q.
we had the empty string being accepted.
Okay.
Yes. Okay? Are we all fine? Okay. So the next thing, I would like to talk a bit about Turing machines. At least in my section, I presented a Turing machine that recognizes the language that consists of all the strings that are of that kind. So equal number of zeros followed by the equal number of ones. I would not like to dwell into that much detail today. I will give a more simple example. So the language that we would like to recognize this time consists of a 0 followed by an non-defined number ones that ends with a single 0. So this is something extremely trivial that you don't need a Turing machine to recognize, right? We could draw a single DFA with an input of 0. This should accept it, right? Even with a single DFA. An NFA should also do the same job, of course, but we will present a Turing machine that will do the same thing, just to show the way to design those things. So it will be in the same idea. You need a starting state. So just before starting for the specific example, I would like to say some stuff about Turing machines. You will always assume that you have an infinite tape of inputs. It has characters. And you start with your pointer, which is the machine, pointing at a specific input character. Let's say that this is the start of your string. It could or could not be the start of a string. It could be that your string was like that. And you start somewhere in the middle of the string. Let's assume that this is not the case, and everything before your string on the tape is empty. And also after your input string. Okay? There is a way to find the start and the end of the string on your tape, right? What did we say? What's the character that shows that, okay, we're out of our string? It's the empty character. And also at the end, right? So if you have a transition that is like that, so Turing machines are defined as the way that we defined machines previously. So we need an input, we read the input, we can do something on the tape, so write, and then we have a transition to the right or to the left. So if I am at a specific state and I read, let's say A, I will write the exact same A and I will move to the right. Okay? So if you follow this rule, no matter how many A's you have in your string, you will move to the right. Okay? If I do the same for a B, my machine will ignore initially all the input characters, A's or B's, or whatever number of characters your alphabet has, and it will move to the end of your input string. How would you make the machine stop at the input string end? If it sees a blank, it should also write a blank because we don't need to spoil our tape. But now I will move to the left. So I will start. I will move to the right when I see an A. I will move to the right when I see a B. I will move to the right when I see a B. A, empty. I stop there and I move left. And this is my end of the input string. It's not the end of my tape because my tape isn't infinite, but it's the end of my string. And this is how I can find the end of my string. Now if you define this in the opposite way, what would this do? Sorry? So it would start, let's say that you don't start anymore at the first input character of your string, but you start here. If it sees an A, it will move to the left, this row. If it sees a B, which is here, it will move to the left. B to the left, A to the left, A again to the left, and when it sees the empty string, it will stop. It will write the empty string again, sorry, the empty character again, and it will move to the right. So this row just finds the start of your input string. And if you find the last and the first character of your input string, you can do stuff with it. Okay? Now, let's get back to our example. You have any questions on that? Simple, but we need to understand this part. Yeah.
That only works if we assume that this machine only starts running at the start of the string, right? Or at the end, I guess. Because then there was the whole empties in the, there was like 4 empty spots in the beginning. So
Yeah, we assume that.
Yeah,
So you say that if I start with an empty string, what would I do?
yeah, it'll just, yeah.
Yes, we assume that the pointer is somewhere inside the part of the string that it has some input character.
Okay, yeah.
So either here or somewhere here, what we have an input character, not at an empty string.
Okay.
Okay. So let's get back to the example. We need to design a Turing machine that recognizes this language. Okay? So what should we do? Starting state. Should it accept or not?
No.
Sorry?
No.
No, because we need to read at least 1 0. So the starting state should not be an acceptance state. Now, what would I do from the start? Let's take the easy case. The case that I read my input the way I want it and I need to accept it. So I read the first 0 from my tape. Okay? What should I do? I should, first of all, I should move to another state. Let's start from that. Should I accept it? No. I read a 0. Do I need to change something on my tape?
No.
Not necessary. So I will write 0 again. And I will move towards which direction? Right. So this is my tape now. Let's say that I start at this point, which is my first input character of the string. This is empty. This is also empty. Here it says 0, which is my first input string. I have a 1 and another 0. This is a string. This is empty. Everything after that is empty. This is a string that I should accept, right? So I get the first 0. I move to the right. And I am in Q1 state now. From state Q1, if I get a what? A 1. So if I get a 1, what should I do? If I get a 1, I should move to the right. So I get a 1. I write what? I don't need to change that. And I move to the right. Okay? For now I have read a 0 and a 1. So I'm at 0, 1. Should I accept it or not?
No.
No, so Q1 should not be an acceptance state. We said that before. Q2 that we are going to define using this transition should also not be an acceptance state. Do we need another state?
Yes.
Why? At this point, I will read the 1. May I read more than 1 once?
Yes.
My question is, Can I loop here?
Yeah.
Yes.
Yes or no? And why?
You can, because you can read any amount of ones before you, but you still need a zero after it before you can accept it.
So if I read a single one, I don't need to accept that. So I don't care that Q1 is not an acceptance state. And I can stay there reading all my ones. What would make the difference for me? The last zero of the string. So if I see a 0, I should write that 0 again, and I should move to the right. And now I have read a 0, 1, 1 in our case, and one more 0. Right? The string that I have read should be accepted by my machine. Sorry. Okay? So this state Q2 should be what? An acceptance state. Okay? And this is the good case, that everything works according to the plan. I get the first 0, I get multiple ones, and then I get my last 0. Now, what should I do if things go wrong?
Go to a hold state.
Sorry?
Go to a hold state.
So I need an acceptance state. This is, let's say, my acceptance state. And I need a rejection state, right? This will be my trust. I will throw everything in there if it doesn't work for me. So, if I read something like this, should I accept it or not?
No.
No, because I have 0, 1, 0, but then it's followed by something that I don't like. I need my last digit to be a 0, but before that, the previous digit should be a 1. Accept or not?
No.
I see a first 0, but then the second digit is also a 0, so I should not accept. So, this is where I am. If my first digit is a 1, should I accept or not? So I know what I should do with a 0, but with a 1 I know that I should reject it. So with a 1, I don't spoil my tape, but I reject it. And in fact, you don't need even to move the head of your tape, because you reject that. No matter what happens after that 1, you're not going to accept the tape that has this kind of string. So, I read my first 0, like in this case. But my next input is not the 1. So I said that we should reject this. So with an input following a 0, that is another 0,
Wait, no. We go to Q2.
I think we need another state.
Yeah.
No, we can have 0, 1.
No, I think when you're at Q2, if you get a 0 or a 1, then you go.
guys, we're here. We just want to define what happens here if you get the first 0 and then it's followed by the second 0.
Yeah, that's okay though.
No, if it's followed by a second 0, then it's fine.
2, 0. The reason why that's wrong is because it's 0, 0 is not.
So 0, 0 is fine. You don't need an arrow at Q1, but
No,
you
0, 0
get
is
one
fine as long as
after
the
Q2.
0, the last 0, the first sequence is.
Why is 0, 0 fine?
Because
One, oh, sorry. One of you should talk. Yes.
You already have 2 lines that say the same thing from Q1.
Well, star means you can have no ones.
You say that this thing will be 0, 0 will be accepted because of this transition.
Yeah.
We will get there. Give me some time. So, I want to reject this though. The machine for now accepts 0, 0. But I want to reject it because 0, 0 does not belong to the language.
Yeah,
No, it does.
Do you mean
Why?
0, 0 followed by anything?
Oh, you mean because of the start?
Yeah.
Okay, that's fine by me. So 0, 0 should be accepted.
Yeah.
Yes.
By just that.
Yes.
Okay. So how would you do that?
Wait, don't we need one more state though?
You need to state.
Why?
Because now, I mean, because the way that is, that would,
Yes.
Oh, right,
under
right.
Q2, should it 0 or 1, Q2 or
We will see what we will do from Q2. For now, we're in Q1.
Oh, with Q1 you don't need anything else.
Okay.
yeah.
Two there, and that has to be 0, 1. So from Q2 to reject.
So 0, 0, just those two characters should be accepted. Right?
Yes.
Yes.
Wouldn't you need to have an empty after the 0, 0 to accept it? So wouldn't you need another thing after, like Q2 wouldn't be your accept state. You would have to see that the one after 0 is empty, and then you can accept, right?
Yes.
So then you're okay.
Say that. Say that. This is what I want.
So wouldn't you add another state
Past Q2.
past Q2, and then
Like that.
yeah,
And then what?
so and then you have that little whatever that is.
The,
Blank.
Yes.
No,
But Q2 is what now?
it's just a regular state.
It's a regular state now.
Yeah. Oh, okay. I said something different.
Oh, come on. I thought you had the idea. That's fine. So, you see here that this is the string that you need to accept. If you have multiple zeros, you cannot accept this. But if you have exactly 2, you should accept it. So, this thing says, I get my first 0. I don't care about the ones. And I get my second 0. I'm in Q2. Q2 is no longer an acceptance state. It's a regular state. But now I've seen my 2 zeros. Yes. So,
Wait, why did we remove the, so we removed the accepting state from Q2 because we have 2 zeros beforehand? Is that the only reason why we're not accepting it as the acceptance state anymore?
the reason is that we need to accept exactly 2 zeros. But if we had 3 zeros, what would happen?
We wouldn't accept it.
And we don't want to mess with that. We just want the 2 zeros to be accepted. Exactly 2 zeros, without anything between them. Okay? So we need the 2 zeros. This is the transition from the first 0. I don't care about ones. This is the transition from the second 0. And then, in order to accept this string that consists of only 2 characters, I know that after the second 0, I have an empty character. This is where my input ends. There's nothing after that. So from here, I will have a transition to an acceptance state that is driven by an empty character. I will not write anything. I will just do this, and I will move, or I will not move, whatever you want to do. I will not move. Yes. You can do much. We need something that works. You can do what you're saying, but this is working. Okay? So for now, I want something that will do the job. This will accept the 2 zeros. This is my first 0, this is my second 0, and after that I have nothing in my tape, so it's empty, and I will accept it. This will also do what? It will read my first 0, it will read any number of ones, it will read the last 0, and after that, since it identifies that the string is done, it will also accept.
Don't we need to double circle the acceptance? Or do we not?
I mean, okay. It's accepted. Yeah.
Isn't there, shouldn't there be another arrow going from Q2 to the rejection state in case you get zeros or ones?
We're not there yet. So, we said we're fine with the first zero. And if the zero is followed by that. At this point, I say that I will accept something, knowing that the next character is empty, so it's the end of my string. Is there any chance that we can do this like in 10 minutes? Any chance, for example. I cannot hear myself. So, I read my first zero. I read the number once. It could be zero. And I read my last symbol, which was a zero. And after that, my tape was empty. So I accept this thing. What if my tape is not empty? So if I have this string that I should accept and will get me to Q2, but after that, I don't have the empty character, but I have a 1. I should reject it. So from here, I should go to the rejection state. With what input? 1. With a 1, I should write 1, and I should move or not.
And shouldn't you, would there be a...
With a 0, what should I do? If this thing is 0, not 1. Same thing.
Why are you using dot?
You could write right or left or whatever you want. It doesn't make any difference. You don't need to read anything after that. You get to the rejection state, you're not coming back from it. Yeah.
If we want to, we can just leave it 0, dash 0. You don't have to write like dot.
No, you need to show what you're doing.
Oh, so we have to like put a dot or something.
Yeah, something like that. You could choose one direction that you want to move to. So let's say right. It doesn't make any difference. Okay? Yes?
In what scenario would you not read the same thing that you're writing?
This is a good question. So the question is, when would you change the thing that you have on your tape? So, the ones that were in my recitation last week, you will remember that we needed to recognize a string that consists of an equal number of ones and zeros. So what I need to do is put a marker somewhere. So let's say that I have my head over here, and I read the first character. I need to know where I started from. I need to know where I counted the first input that I had. So instead of leaving the 0 there and having no clue what happens, I would substitute that 0 with an X. I would expand my alphabet to 0, 1, and an X, so I can read that X afterwards. And now, when I move to the right, I do my magic over here, I don't care. And when I move to the left again, I know that my marker is here because I see an X. It's no longer a 0, because this would also be a 0. It would not make any difference. By now that I have an X, I know that I started from here. And since I started, I can do whatever I want with the next input character. And so on. So this is the case that you can use to read and write something on the tape. If you don't need to spoil the tape, because you don't want to come back and know where you started from, you can leave it as it is. Okay? Are we all cool? And I think that this should do the work. What if I read the single 0 though? So what I can do is draw another arrow here with an input that is empty. I will still write the empty, and I will not move. Yes.
Before Q0, you would also want to specify that there's an empty, right?
Before Q0,
So that you don't have anything before the zero. Alright, never mind.
sure.
Wait, so, as you were saying, like, can we just assume that we're starting from that point where it's the first value we're getting is 0?
Yes.
We can assume that.
You can assume that you start from the first character of your string. You can assume that.
So yeah, so to reject the empty string, we have an empty from Q0 to reject it.
This machine rejects the empty string. The machine rejects the empty string. An empty string would keep you at Q0. So Q0 is not an acceptance state, so it will reject. Everything that is not an acceptance state rejects. Yeah.
Actually, so talk about the counting one.
Okay.
Mark it. So you mark the first zero, right? And you go all the way to the right, you get back, and you mark the second zero?
Yeah.
What's the point of marking? The point you start and end?
So to see how many times it's supposed to.
What we saw last week was that I need to count my first zero out.
Yeah.
I will move to the left until I find my first one.
Yeah.
I will cross that one with a different input symbol. And I will move backwards towards my marker.
Yeah.
Then once I find my marker, I will move to the right. And I know that this is my second symbol. I will cross this with the same exact symbol. And I will move again to the left until I find the one.
Yeah.
If this procedure ends with the exact same number of x's and y's, and I don't have a 0 or a 1 that is more than the previous, then it means that my string has exactly the same number of zeros as the number of ones.
So it can at the end of this whole process, it can count how many x's and y's there? The machine?
No, but it will not count. So it's not like a counter. But the procedure will stop if it doesn't have any more zeros or ones to read. If the tape somewhere has a 1, it will go to the right and it will find that 1. And you will make the machine so that if it finds a 1 that is unbalanced, it will be in a rejection state. Or if it finds a 0 that is unbalanced, it will also be at a rejection state. But if it only finds x's, and if it only finds y's, it means that there's no other symbol. And the x's and y's should be the same in number.
Okay.
And then the number of symbols should be exactly the same.
Do you only go back when you hit the end of the string, or when you hit a 1? Like, let's say you're counting zeros, right? You get counts for 0.
Yes.
And you travel to the right.
Yes.
Do you go back to the left when you hit a 1, or when you hit the end of the string?
No, when you find the one.
Find 1.
You need to cross the ones in the way that you find them.
Okay.
I found the first 0, I moved, I found the first one, I crossed it. I get back, I found the second 0. I get back, I found the second one, I cross it.
So every time you hit something you're looking for, you cross it, that's when you go back?
Yes.
Okay.
So the whole point of us using X and Y markers was just simply to be able to find the number of a certain element within the Turing machine.
Yes.
But let's just say hypothetically we want exactly, let's just say like 3 ones, right?
Yes.
Remember how we have the self loop and it's the 1 star? We want specifically 3. We would write, empty 0, 1, 1, 1.
If you need
0, empty, empty.
If you need something that is that explicitly defined, so let's say I need 5 ones,
Right.
you don't need this kind of thing that will work for any number of zeros and ones. You can define a DFA, think of it like that. You know how many states you need to count, so you can get exactly the number that you want. It could be infinite states, not infinite, because we're talking about finite machines. But it could be 1,000,000 states. I will count 1,000,000 ones. Not a single one more or less. But I can do this using different states. This thing will work for any number of zeros and ones that they're just balanced.
But the one thing I will say there, right, like in specificality, if we want 3 ones here, right, DFA wouldn't be able to do it because DFA doesn't have memory, which is why you want to go use the Turing machine, right?
Can I use a DFA to identify if I have exactly 3 ones in a string? Guys, a little quiet, please. Can I use a DFA to identify if I have exactly 3 ones?
Yeah, you just explained.
I have a starting state. I don't care about zeros. I count my first one. I don't accept this. I count my second one. I don't accept this. And I count my third one. And at this point, I accept. I don't care about zeros. I can look as many times as I want with zeros. If I got more than 3 ones, I will reject.
Okay.
This is a DFA, and it has some kind of memory in the way that you want to define it. Because it's not memory, because it is really explicit. It knows in advance how many zeros it needs, or ones. Memory means that I see something different, and I need to understand. And this thing, so this language, 0 to the n, 1 to the n, should work for any number n, not just 3. If I need 0 to the third and 1 to the third, I can design a DFA that will do that. It's really easy.
Okay.
No matter what number, anything that is predefined is easy to design. Are we all fine? Any questions?
For Q2, what about 0-1 and 1-0? Would that go to the reject state?
Shouldn't it? It means that you have whatever input string that has reached Q2. So let's say that this one is the one that you have. And the next character that you read is not the empty character. But it means that there is another character here, 0 or 1. So it really spoils everything. You need this kind of string, or any number of ones between 2 zeros. Clear? That's all. Yeah.
For the final, how many bumps can we expect there to be?
Many. You have 3 hours, guys. Last time you had 1 hour and a half or something. You have 3 hours. It will be designed to be for about 2 hours, but you will take more than that. That's for sure. Yeah.
So on the last test, we had a midterm. We had that sheet that gave us like Morgan's laws and like certain properties.
You will have something like that, I think, if you need that, but I'm not sure that you will need that. If you need something like that, though, you will have it. Yeah.
Do you know there's going to be extra credit on the final exam?
I'm not sure, but if there is, you should try it, because last time it was the easiest thing to grade. I mean, it was like we threw stuff away. And it was easy. It was a simple induction problem. Yeah.
What was the average for quiz 6?
I don't know. I graded quiz 6 yesterday. Not yesterday, sorry, problem set 6 yesterday. It was decent. Quiz 6 was decent.
It's like 14. It's like 14. Yeah.
14?
Yeah.
The funny thing for my share at least was that I had 20s and I had 2s or 3s. So the average is 14, but it's not, the dispersion is amazing. Yes, I'm coming back.